All right, we are doing lesson 30-1 on page 411 of your Springboard book. If you do not have your book today, go grab some Cornell paper or see if I have some extra copies of the lesson. Okay, let's mark up our text. So we're going to model linear relationships between quantities using functions. Okay, then we are going to identify and represent linear functions with tables, graphs, and equations. We've been doing a lot of this already. This is kind of just a review lesson. All right. Our suggested learning strategies are marking the text. That's what we just did. Note taking. All right. You're used to doing that. Interactive word ball. There's a word ball up front. Create representations. That's making the graphs. And look for patterns, which is when we look at tables to see if we can find the slope. All right, here's our definition. I'm going to put a star by this because this is something you do need to learn. You need to have this word memorized. The rate of change in a relationship represents the ratio of the vertical change in y to the horizontal change in x. Okay, and then they put like a little picture down here for you. So whenever we're talking about slope, which is the same way as rate of change, by the way, I'm going to write that here. Because really, they have just given slope another name. It's the same as rate of change. And the reason they call it a rate of change, because rate is a term that kind of means moving, or actually we'll just go with moving, and change is when something, changes. So you're looking at two things and you're seeing at what amount do they change. Which sounded confusing, but you'll get the hang of it. All right. I'm going to put in some actual numbers here really quick just to make sure that we know what's going on. So it says that this is 3 and this is 5. Well, I'm just going to make up something. So I know if this was 4 and there's 3 in between, this would be 7. And I know that if this is 5, all right, and let's say this point down here is 0, 4, okay? If this is 0, 4, and this is 0, 7, all right, letter B would have to be, let's see, that's 4 to 7, so that's 3. We want 0 to this to be 5, so we'll do 5, 7. All right, now that looks a little confusing, but basically I just wrote in coordinate points to pretend like this was actually on a graph. You do not need to know how to make up coordinate points. I just wanted something in here so you could look at it later. So what this means by vertical change, it's telling us our vertical change is 3. If we didn't know that, we would plug in our coordinate points and do 7 minus 4 on top. It's telling us our horizontal change, which is from here, is 5. If we didn't know that, we would plug in our x's, which is 0 and 5. And then we just subtract. And we end up with the same answer. Okay, the height of a water in a pool is shown on the graph below. Determine the rate of change. So we're determining the rate of change of the height of water in the pool. All right, so it just wants the slope. It says rate of change, but it means the slope. So we're going to pick 2 points. I always try to pick smaller points so it's easier for me to subtract. I'm going to pick 0, 0, and 1, let me undo that because now I can't really see very well. 0, 0, and I think the next one I'm going to pick is this guy. And the reason I skipped him is because he's not actually in this cross, so it's not easy for me to see what point that is. If I skip to here, that is on an easy cross so I can tell what point it is. All right, let's go back to my black. This first point up here is 2, 5. The second point over here is 0, 0. Okay, we want our vertical change over our horizontal change, so we'll do the vertical first and the horizontal. Our vertical, we're going from 0 to 5, so that's going to be 5. Our horizontal, we're going from 0 to 2. Okay, so that's going to be 2. We put our vertical on top, so 5 over 2, which simplifies to 2.5. We usually like to write it as a fraction because that tells us to go up 5 over 2, but you can also write it as a decimal. All right, and we want to write this as a sentence. I know we haven't been doing a lot of sentences, but we need to get used to that because in high school we're going to have to do a lot. So I'm going to do a little arrow here because I don't have enough space. You should have enough space to write it. So we're going to say the rate of change is 2.5 inches of water per minute. Okay, and the way that you find that is water per minute, since your water is your y that goes on top, height in inches, which is water going up, and then the minute is your x's, and if we look, our x would be on bottom. So it's water per minute. Then it says describe the rate of change in this graph. All right? Basically what that's asking is it positive or negative? So positive is a slope that goes up, negative goes down. We can see that this one goes up, so it has a positive rate of change. Period. All right, you can also see rate of change from a table of values. The table shows the data from the graph above. How is the rate of change from the graph above represented in this table? All right, so it's telling us first we look at the change in time, okay? And you can color code this if you want, I'm going to. So step 1, look at the change in time. Okay, so I'm going to pick these two. Then it says step 2, look at the change in height. So I forgot to write the change in time was 1 because 1 minus 0 is 1. The change in height was 2.5. Okay, and it says write the ratio of change as a ratio of vertical change to the horizontal change. So we put our vertical over our top and our horizontal on the bottom. That's going to give us 2.5 over 1. Then it gives us this long sentence. So this is what it wants you to write. Okay, and I know this is longer than we're used to. You don't have to write that much, but this is just a really good example of an A+ answer. Okay, try these A. The table below represents the fare schedule for a taxi cab driver's fare. Determine the rate of change. All right, so I'm going to do my horizontal change second because it's on bottom. So I got my vertical over my horizontal. Okay, so I'm going to pick my 2. So this guy right here, I'm going to assume that's my x, and I'm going to assume that's my y. Okay, remember horizontal is always x, vertical is always y. Okay, so I'm going to look at 0, 1. 1 minus 0 is 1. Then I'm going to look at 5, 8. 8 minus 5 is 3. Okay, so then I just put my vertical on top, so 3 over my horizontal, which is 1. And we always like to simplify, so that's just going to give us 3. So the rate of change is 3 miles per minute. We want to make sure we get that label on there. Oh, I messed up. It's not 3 miles per minute. Okay, 3 miles per dollar. There we go. All right. Interpret the meaning of the rate of change in this context. Okay, I kind of skipped ahead. I guess they wanted a sentence here. So you could have just written 3 for the determine the rate of change. Okay, you can also see rate of change by looking at the equation. So now it's giving us an equation. The equation for the data represented in item 1 and example A is y equals 2.5x. How is the rate of change you determined in item 1 an example of A represented in this equation? So this is looking at our mx plus b. You need to have this memorized. You will start getting pop quizzes on that. So if we write our equation under that, we're going to get 2.5x equals y. Because we don't see anything there, we're going to assume that's plus 0. Okay? So that means our slope is 2.5. Our slope's always the one next to the x. And our y-intercept is 0. If we look, we can see 0, 5. That's our y-intercept, and that matches. And our rate of change, or our slope, oh, hold on, sorry. This one's example A. Example A is this guy. So if we see here, our y-intercept is 0, 0. That's what we want, okay? And then our slope is 2.5. So if we plug that into our equation, we will put 2.5 in front of the x plus 0 equals y. So you get 2.5x equals y. So you literally are just plugging your information into the equation. So the rate of change, if we want our textbook perfect answer to this question, we would say the rate of change described in item 1 in example A is represented in this equation by the coefficient 2.5, meaning that 2.5 inches is added with each additional minute. So what we would say, since it's asking just about the rate of change, I'm going to simplify that, is 2.5 is the rate of change for example A, and it's the coefficient, and if we don't remember what that is, that means the number in front of the x. Sorry about that. And it's the coefficient of x in the equation. Alright, data points are linear if they show a constant rate of change. So again, rate of change is slope. Constant means that it's going to be a line. When you plot the points of a linear data on a coordinate plane, they lie on a straight line. The points represented in item 1 and example A are linear. Jamila is using a straw to drink water from a cylindrical cup. The height of the water remains... First of all, can we just point out all cups are usually cylindrical? So we got our cup here. I put a mug, a little handle. Okay. Cylindrical cup. The height of the water remaining in the cup is a function of the time that the person has been drinking. The following graph gives the height of the water at different time intervals. Okay. So we have 0, 10, 20, 30, 40, and 50 is the time. And then we look at our graph here, and we can fill that in. So at 10, let's look at 0 first. Skip one. At 0, it says it's 15. At 10, it says it's between 12 and 13, so 12.5. At 20, it says it's 10. At 30, it says it is between 7 and 8, so 7.5. It's always 0.5 if it's in between two whole numbers like that. 40 is going to be 5. And 50 is going to be 2.5. Alright, so we did that. Let's see what our next step is. Alright, describe any patterns you observe in the table about the height of the water over time. So if we look at our table, we can see that it's going down. It started at 15 and it went down. So we can say the height of the water, and you can say went down, or we're going to use some fancy math words, decreased, which is the same as went down, over time. Is the relationship between time and height of the water linear? So does it look like a line? Can we see that line in the graph is what that's asking. So go ahead and think about that for a second. Alright, now hopefully you don't think about it too hard, because we're literally going to say the graph shows a linear relationship because the graph is a straight line. Sorry, this pen's a little weird. So if we go back, we can actually connect these dots and get a straight line. Alright, now I want us to explain using the table. In order to have a straight line, we have to have a constant rate of change. So we're going to take 2 points. So this is going to be our horizontal change, and that equals 10. We're going to take the other 2 points. That's going to be our vertical change, and we know it's going down because it went from 10 to 7.5, so it's going to be negative. 10 minus 7.5 is going to be negative 2.5. Okay, now we're going to plug them into our vertical change over horizontal change. So negative 2.5 over 10. And that reduces to, what does that reduce to? You know what, we're just going to write that as a decimal. Okay, go ahead and try to plug that into your calculator, and I'm going to go get my calculator, and let's see if we can get it first. Alright, so we've got negative 2.5 divided by 10, and hopefully you got 0.25, or negative 0.25. So that's our rate of change, or our slope. Okay, so real quick, we're going to check, because we answered part of the problem, but we didn't answer the whole. So we see that this right here has a slope of negative 2.5. We really want to make sure it has to be consistent. I'm going to check this one too. 40 to 50 changes by 10. And 5 and 2.5. So that would be 5 minus 2.5 is going to give me negative 2.5 again. Alright, so those match, and because they match, it's saying it's a constant slope. So one side of the table always goes down by 10. The other always goes, alright, it doesn't go down by 10, it goes up. Because it went from like 40 to 50. Other goes down by 2.5. And because it always goes up by 10 and always goes down by 2.5, it's linear. Okay, what is the change in water level from 20 seconds to 30 seconds? Well, that's just asking, so we look at our 20 to 30 seconds, it was 10, and it went down 2.5, so we're going to say the water went down 2.5, and what was our label? Centimeters. Determine the rate of change for the level over time. We already did that, okay, right here. So the rate of change is 0.25, negative 0.25, because it goes down, centimeters per minute. Oh, sorry, seconds. Okay, go ahead and try number 9 on your own. Okay, you really should have gotten about 2 centimeters. And the way that you're going to do this is you're going to look at your table and you're going to see that, like, we know it goes down 2.5 seconds, 2.5 centimeters, okay, a minute. And at 50, it's 2.5, so it's going to be a little bit smaller than that. So as long as you get something below 2.5, it's fine. 2 centimeters would have been a good guess. All right, write a function that gives you the height of the water in terms of the time. Okay, so this is where we're doing our slope-intercept form. So M is always our slope, B is always our start. So if we flip back, it starts right here, and that's 15. So plus 15. And then we just said our slope was negative 0.25. There we go. That's all we had to do. How long will it take for Jamila to drink all her water and completely empty out her cup? Use multiple representations to justify your answer. Okay, so if we know x is going to be, so our x is the water, and our y is time, okay? We want to know this. This is what the question asks. But the water, when it is completely out of her cup, it's going to be 0 because there's no water left. So we're going to plug 0 into our equation. And the parentheses just mean multiply. Then we're going to solve. Negative 0.25 times 0 is 0. 0 plus 15 is 15. So it will take oh no, Miss Peacock messed up. Miss Peacock flipped them. Hold on. Sorry, we're going to be erasing. Erasing. I flipped them. Okay, if we look back, height of water is our y, and time is our x. I flipped them. That's why it's always good to double check me. So our x is time. Our y is water. So same basic thing. When you don't have anything in the cup, it's 0. We're going to plug that into our equation. All right, so first I'm going to get my 15 on this side. All right, now I'm going to divide to get rid of that decimal. Okay, and that's going to give me x equals 60. So it takes 60 seconds for her to drink it. Drink all the water. All right, that is all. You're going to practice by completing the check your understandings. For this lesson. Make sure you raise your hand if you have any questions. I'm going to get fingers. 5 fingers. Okay, clearly not a good artist right there, but there we go.